Hi Matrix, hi grade 11s, hi grade 10s, welcome to Matrix Uploaded. My name is Mark. If you don't know already, I'm the maths dude on Matrix Uploaded, and we're going to do trigonometric graphs today. So grade 10s, fasten those seatbelts. The aeroplane is about to take off into the trigonometric functions. We're going to start off with basics, grade 11s and 12s, listen up as well, and then we're going to get more advanced in the lessons. Okay, so keep focused. And now, grade 10s, you probably haven't seen this. Grade 11s, you have. Maybe not, I don't know. And Matrix, definitely. But we're going to be looking at the graph now of y equals sine, y equals cos, and y is equal to tan x. Now remember, in the previous lessons, what have we looked at? We looked at parabolas, we looked at hyperbolas, exponential graphs. But now this section takes trigonometry and it takes it a step further. Okay, and we've looked at a bit of trigonometry anyway, so we've looked at functions, and we're going to take this further. Now let's see if we do something different with this. Now I'm going to start off with the graph of sine x. Okay, now how do we draw a graph like this? Let's have a look. Okay, so we're looking at the graph of y is equal to sine of x. Okay, sometimes some books use theta as well, which is also fine. Now how do we basically draw this graph? Now listen, grade 10s, this is probably new to you. What you're going to do is you're going to get your calculator. Okay, I want you to get your calculator, make sure it's on degree, and then what we're going to do is we're going to have some fun. Okay, now watch this. How this graph works is if you look at naught here, these we're going to put naught degrees here. These, by the way, are all going to be degrees. Okay, but we're going to put the degrees on the x-axis. We're not going to go and form your naught up to 90 and maybe 30 degrees. We're going to put them on the x-axis. Now this is something very different to you, or something new. Now look at this. We've got all these values. You've got naught, say 30 degrees is maybe there, and then you've got 60 degrees, 90, and so we go on. And we've got 4 little areas or quadrants that we're working with. Now let's see what happens if you plot a few points. If we look at x as naught, what would be the y value if x is naught? Well, that, if you look at 0 degrees, your calculator, push sine 0 for me quickly. What do you get? You get 0. So I'm going to put a little dot on the 0. Now go to 30 degrees. Let's suppose we looked at 30 degrees. Okay, what would be the sine of 30 degrees? Well, let's see. The sine of 30 is going to be, in your calculator, a half, or 0,5. So what do? We go up to a half there, and 30 degrees, we put a little dot there. So 30 degrees in line with a half there. Okay, now if you go to 90 degrees, let's see what happens if we go y equals the sine of 90. Okay, and your calculator, just check it for me, is 1. So this goes up here and we put a little dot in line with the 90 degrees and 1. Now if you continue, check out what we're going to get is we're going to get a little, if we put lots of little values in here, we're going to start getting a curved thing here. Okay, now what happens at 180? Well, let's check. Y is equal to sine of 180, and that will give us 0. Okay, all right. And if you put a 0 there, what do we get? A 0. And what about 270? Let's see, y is equal to sine of 270, and that will give us -1 if you work it out in the calculator, and 360 gives you 0. Now people, I've selected 0, 30, 90, 180, 270, 360. You can of course choose 45, 40, all those values, and if you keep plotting the points, the graph will be made up of millions of little dots, and really what the sine curve looks like is something like this. It goes very much like this. It goes there to there, and it turns, and then it comes down. Look at this, comes down to 180 and goes to 270. All these little dots here that form this graph that we call y is equal to sine x. Now the restriction, we're going from 0 to 360. Later on we can get negative angles. We can go to -90 degrees in grade 11, and also we can go to angles bigger than 360 degrees, because if you're on the x-axis you can extend those. But now notice some very interesting things about this. This graph goes up and then it goes down, and what we say is that the amplitude, now here's an important word, the amplitude of this graph is going to be half the distance from between the biggest point. So if you take the highest value here is 1. The lowest value is -1. Now the distance from here to here is going to be a distance of 2 units. Now the amplitude of this, the amplitude is half that distance. So what's a half of 2? It's a half of 2, which is 1. And notice also, if you look at the sine graph, that number next to there tells you the amplitude. In other words, we go up to 1, all the way down. It's almost like a deflection from the horizontal. So the amplitude is you go from the biggest point to the lowest point, and we've got a distance. This distance is 2, and we halve it, and that gives us amplitude. And then what do? If we carry on, we can look at, for example, if we go to the next slide, what about the graph of cos x? Okay, this is an interesting one. Okay, if we have a look here, the cos graph, the cos of 0 is 1, the cos of 90 is 0, the cos of 180 is -1, the cos of 270 is 0, and the cos of 360. I want you to check this, and when we come back, I want you to see if you can draw this graph. I want you to try it now, and when we come back, I want to see if you know how to do it. Stay with us on Matrix Uploaded.